Yeah, chapters 1 and 2, the problems we've been working on and everything. So it's it's all in there already. Okay, can everybody hear me? Can you hear me there?
Yes.
Okay, basically I discussed with the other students, the way it's gonna work, we have 5 students coming for the exam next week at 8 o'clock. So 5 of you can come at 7. If you wanna come at 7 and take the exam at 7 o'clock next Thursday, a week from today, please email me and let me know, and we can kind of fill in the blanks regarding some of you that wanna come at 7 o'clock. The rest of you will come at 8 o'clock with the sports people, okay? Does that make sense to everybody?
Yes.
Okay, wonderful. All right, thank you very much. Okay, now I passed back the quizzes, the previous quizzes and worksheets to the students here. If I still have copies of yours, come pick them up in my office, or I'll give them back to you at 11 o'clock when we have the your little quiz. So come to 3:15 at 11 o'clock, and you'll get the same 25 minutes to half hour that the students did when we're done the lecture portion today. So basically, it'll work with there's a couple of you that made other arrangements. If you made other arrangements because you had to work, I think there's one person that had to work. If you could come at 9. If you're on campus, if you could come over here, be here about 9:25. There is one desk available, so you can come at 9:25 then and take it with the other group. Is that okay? I'm not sure which student it is, but somebody had to work at 11 o'clock, one person. So I think you know who it is, whoever that is, okay? And the others, one other student had to make arrangement to take it during my office hours. So, all right, so what I'll do now is continue where I left off. I'm gonna share the screen now. Hold on a sec, please. Just a sec here. Okay, now this is mass relationships, and this is where we get into the math. And we'll start talking about chemical reactions. I'm going to switch back to Chang next week again, so we get the combination of both of them. Can all of you see the screen?
Yes.
Okay, you can hear me fine too. Good, wonderful, thank you. All right, now, basically the key thing to understanding the nature of chemistry is, could one of you guys, could you shut off the lights? One of you guys do it. No, you can stay there. You can go get it. I didn't want her to. Go ahead, shut off the lights for me. Okay, basically the key thing to understand the nature of the math problems that you were working on in chapter 1 with all the different conversions. Here we're talking about chemical equations. And so in a way, it's kind of like taking oops, let me go back. It's kind of like taking A plus B goes to C equals C plus D. Okay, or equals E, something like that, okay? Chemical reactions are the same thing. So what is this chemical equation saying below it? You have two hydrogen molecules plus one oxygen molecule rearranges to form water. So essentially 2 molecules of hydrogen gas react with 1 molecule of oxygen gas to yield 2 moles. So this is react with. This is react with here. This is 2 molecules or moles. It could be moles also. Okay. why does it go from molecules to moles? What's the difference between one molecule and one mole? Well, one molecule is just one item. A mole is 6.022 times 10 to the 23rd, okay? So it's just a matter of bulk, but you're still using the useful units. So essentially when you have all these break and then reform to form these molecules of water. So you have liquid water at the end. Now, in reality, it could also go to gas. Under normal circumstances, if you burn hydrogen, this is one of the labs you're going to be doing this week. Some of you are doing the virtual lab. You're going to see hydrogen burning. And I will post a video also I want you to look at too of the Hindenburg disaster. And so you can address the issue of that old hydrogen balloon burning down and dropping all sorts of water and such like that. It's pretty cool, the chemistry. Thankfully, not many people died. A lot of people got away. But the point is, it was quite a disaster when it happened. And I will place a video about that. But basically, hydrogen burns with oxygen to form water. And under certain circumstances is liquid, under other circumstances it's a gas, okay? So essentially what you have are essentially a chemical equation associated with this. The microscopic and the macroscopic work hand in hand, okay? Now, look at another thing regarding the nature of these. Okay, two hydrogens goes to form two waters. Okay, so you can divide both sides by it to get one. So you can have 1 equals, and this would be moles of hydrogen and then moles of water. You could have 2 moles of water require 2 moles of hydrogen. What cancels? The 2 here. So essentially you've got a conversion that goes from moles of hydrogen to moles of water, okay? So those conversions are very useful later on in the chapter, and we'll be discussing that. But that's the first step. And Hein, I believe in chapter 7, starts with the break it down of going from grams to moles. So basically the first step is you go grams to moles, and this is moles to moles. And then in the case of a liquid water, this would then go moles to grams again. So this is the beginning of it there. So you've got conversions using grams to moles and moles to grams. What is the conversion unit for grams to moles? And I addressed it last time in lecture. What is the conversion unit for grams to moles? How many grams per 1 mole of hydrogen? Huh? For moles of hydrogen, how many grams per 1 mole of hydrogen? Well, for 1 mole of hydrogen molecules. 1 plus 1 times 2, right? So it's 2. So you have 2 grams of hydrogen equals 1 mole of hydrogen. So that's the conversion factor you can use going from grams to moles. So if you have 56.5 grams of hydrogen, how many moles would that be? Well, you put it down here, 2 grams of hydrogen equals 1 mole of hydrogen. What cancels? Grams of hydrogen cancel. You now have that math. You now have moles. So that's the first step, going from grams to moles. Because when you're going to do measurements in the laboratory, you measure out the grams, you measure out the weight, and then you switch to moles. So essentially, there's 2 different aspects to it, going from different individual molecules. You break them up into pieces, you put them together like a model kit. Otherwise, many millions of things, a mole of molecules react with another mole of molecules, or in this case, 2 moles react with 1 mole there to give 2 moles of water. And so essentially that's that. So essentially what you have to do is remember that the law of mass conservation says that essentially in chemical reactions, chemical reactions, matter is not created or destroyed. Matter is not created or destroyed. It rearranges. Okay, so essentially you have here sodium plus chlorine. Sodium plus chlorine goes to form sodium chloride. Okay, but chlorine is a gas. It is Cl2. How many chlorines are on the left? 2. How many on the right? 1. So you got to put a 2 in front. So you start first with this one, go over to that side. Now, how many sodiums are on the left? 1. How many on the right? 2. So you go back the other way and balance that. So that gets the 2. So now you have this, and it's now balanced. So the best way to do it is to go back and forth across. Now let's use another example. Okay, aluminum plus oxygen goes to aluminum oxide, Al2O3. Okay, how many aluminums on the left?